This is the multiple choice question from the Lebesgue measure. If phi equal to summation on ai into the characteristic function chi ei for mutually disjoint ei that are measurable sets of finite measure. This is very important. These are the disjoint measurable sets of finite measure. Then the integration of phi x dx is equal to what? What is the integral of this simple function phi? Options. Which of these options are correct? We need to check this. So this phi is given to us, and if I take the integration of this phi x dx, then this will be equal to the integration of the right hand side with respect to m. M denotes the measure of the set. So this is equal to taking the summation outside and the integration of ai multiplied with chi ei. Then we can take this constant ai outside of this integral. So this can be further written as summation I going from 1 to n, because this is your constant. So I am taking this outside of this integration, and the integrand is chi ei with respect to m. Please note that the integration of chi e is always equal to the measure of this e, right? So the integration of chi ei will be equal to the measure of this ei, right? What is chi e actually? What is the characteristic function? It is equal to 1 for x belonging to e and is equal to 0 for x not belonging to e, right? For the elements that belongs to e, x. For all those x that belongs to e, this value is 1, otherwise it is 0, right? So the integration of this characteristic function for this measurable set e is equal to the measure of e. So this is equal to the summation I going from 1 to n ai. The integration for this is the measure of ei, right? So which option is correct? Option A is correct. Please note that any simple function that is phi can be expressed as finite linear combination of the characteristic functions of measurable sets, where this ai, these are the distinct values of the range of phi. In the range of phi. Secondly, we take ei to be the set of all those points such that phi of x is equal to ai, right? In its canonical form, these sets are disjoint and measurable. So if you take the measure of the union of all these ei's, you will be getting this to be equal to the summation of measure of ei, right? And third, what is chi ei? It is the characteristic function which is equal to 1 for x belonging to ei and is equal to 0 if x does not belongs to ei. And the definition for the integral of this simple function is equal to the summation, the finite summation on the product ai multiplied with the measure of ei, right? Some of the properties for the linearity for constant c, d and simple functions phi and mu. This integral is equal to c and d are constant. So this is equal to the constant c multiplied with the integral of phi d mu plus the constant d is multiplied with the integral of psi d mu, right? Then for the monotonicity, if phi is less than equal to psi for all x, then integration of phi will be less than equal to the integration of psi, right? Then is the additivity. If a and b are disjoint measurable sets, then integration of phi d mu over a union b, that will be equal to the integration of phi over a plus the integration of phi over b. Then for the null sets, if measure of E is 0, then integration of phi over E will be equal to 0 regardless of its values, right? So this is all about for the simple functions and the example. Thank you so much.